Hello, this is Miss Kierstead, and today we're going to do a little video about which formula to use for which triangle, because sometimes I think that's the hardest part. Y'all know how to, once you get the formula, you can figure out how to solve it, and if you need help with that, that will be a different video, but this one is just which one do I use when. So the first thing you're going to look for when you're looking at your triangle is there that little box in the corner? In other words, so we're going to use SOHCAHTOA anytime we have a right triangle. And you can use law of sines and law of cosines in right triangles. You won't get the wrong answer, but I think it's simpler to just use plain old right triangle trig, with the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. The other thing that you can use when you have right triangles, so right triangles, you can use SOHCAHTOA. That is also the time when you can use the Pythagorean theorem, that a squared plus b squared is c squared. So those are your main tools right there, okay? So then we can go on to law of sines. When do we use law of sines? We use law of sines when we have an angle and the side opposite of that angle. And the one thing you have to remember is sometimes that angle opposite a certain side can be hidden. Anytime you have two angles of a triangle, you basically have all three, because if you have two, you can always subtract those two from 180 to get the third angle. So definitely anytime you have two angles, if we have angle, side, angle, if we have angle, angle, side, and there's another one, you don't have to have two angles. You can have side, side, angle, although that's a tricky one. But again, you would have to have an angle and the side opposite that angle. And then finally, when do we use law of cosines? And that's basically all the rest of it, all the other cases, which turn out to be when we have side, angle, side, or side, side, side. So let's just take a quick look at some pictures and see if we can make sense of why. The other thing I always say is you try and fill in the things you know in the formula, and if you don't have the right pieces, then you know it's not the right formula. So here are two pictures right here. Stop the video for a minute, see which one you think you should use and why. So coming back, hopefully, on this one right here, you would see that right triangle, and you know we want to do SOHCAHTOA. So then your job is to figure out which one. Am I going to do the sine? Am I going to do the cosine? Am I going to do the tangent? And that is all about what pieces do I have. So if I'm using this angle, this would be the opposite. This would be the hypotenuse. And then I would want to write, since it's opposite and hypotenuse, I'd want to write a sine equation. And I could do sine of 27 is 8 over x. And then I can solve for x. I have one missing thing, and I can solve for it. Okay, if we come over here to the other one, hopefully, so I look at this picture and I say, well, I have an angle and a side. Or I see this really. I see a side and the angle opposite. That tells me law of sines, because I can do sine of 80 degrees over 18 is sine of 37 degrees over, this would be little d, this would be little e. And I can even solve for big E, again, by taking 37 minus and plus 80 and subtracting that number from 180 to get E, and then I could find side E. But this would be a law of sines. And I knew it because I had a side and the angle opposite. I had one of those pairs to fill in, and I had one more piece. Okay. Again, pause the video for a minute, see which ones you think you would use for each. These look really similar, but they are a little bit different. Okay, so coming back, this one right here, what pieces do I have? Well, that's a side. This is an angle. This is a side. And if I try to use law of sines, if I have this side, I do not have the angle opposite. If I have this angle, I do not have the side opposite. And if I have this side, I do not have the angle. So I don't have any pairs of sides and angles opposite, which tells me I need to use the law of cosines. And then the thing about the law of cosines that you want to remember is whatever angle I am using, the thing that's on the other side is opposite. So in this case, again, the letters A, B, C don't really matter. If I call this little a, my formula would be a squared is, and it doesn't matter which one is B and C, but we could do 18 squared plus 25 squared minus 2 times 18 times 25 cosine of that angle. Okay. Because again, law of cosines, because I don't have a side and the angle opposite. And when I come over here, now I'm given an angle and a side and another angle. I have two angles. And again, in this picture, it doesn't look like I actually have a pair of side and angle opposite. I have this angle, but I do not have the side opposite. I have this angle, I do not have the side opposite. I have this side, I do not have the angle opposite. But because I have two angles, I could subtract 31 and the 113, and I can get this angle, whatever this is right here, and then I could set up my law of sines. Got one final quick one. When I have all three sides, I definitely do not have a side and angle opposite, and this is going to be law of cosines. And again, whichever angle I am solving for, let's say I want to solve for this angle, then this would be what would be alone on the other side. If I wanted to solve for, say, angle C, then this would be the angle that would be, oops, this would be the side that would be opposite. So that way I would do this one, right? And these are all using the same numbers. But I'd be solving for a different angle, but I have to, these have to be opposite each other. These right here have to be opposite each other. That's what's important with the law of cosines. So hopefully that helps you figure out what to use when.